we're going to have some fun in this session, so let's go ahead and get started. It is now 5 o'clock. We're going to have to rock and roll through this content, but you're going to see a lot of interesting things here, I hope, that will also inspire you to go challenge yourself and test some of these ideas and try some of these things also. So we're here to talk about serverless Java, serverless function-based programming, if you will, running it inside a serverless architecture. Our sign is falling down again, isn't it? Okay, so like before, we have the slides available at a URL. You can see it's bit.ly serverless Java SG. That'll get you access to the slide deck, get you access to all their other links you'll see inside that slide deck, and you will see some of the ones we did earlier. So just watch that URL because that's the one you're going to want when you say, hey, I want the slides, because that always happens. And I'll say, did you go to the URL? You're like, no, I forgot the URL. Try to remember it this time. It's just bit.ly serverless Java SG. You'll see it a few more times in the presentation. Okay, let's get started. This is actually the new branding for Red Hat Developer, the developer program at Red Hat. So I threw it in there, not the previous one as you saw. And that's a sponsoring entity from developers.redhat.com. That's where Kamesh and I work. And these are all the free ebooks we mentioned in our keynote earlier today. Make sure you grab a copy of those things, including Clement's book on reactive microservices. And you'll notice there's two very interesting links here at the bottom, the Istio tutorial and Service Mesh. So this one is a GitHub README where you can actually install everything locally. This one's an online interactive solution where you just learn it. You just try it. There's no installation for the learn.openshift.com. But what we're going to talk about now is this FAS tutorial, Function as a Service, and the serverless one. So everything that you hear from us today, you can kind of try yourself online. All you have to have is a browser. You can go to learn.openshift.com and just give it a try. Okay? All right. Don't forget about Etsy Yanaga's book. That's the one we passed out last year. And there's also this book that we mentioned earlier, but the Istio book is the Service Mesh book, and we're running that workshop tomorrow. Okay? I think the workshop's already sold out. There's already the appropriate number of people for the workshop, but we'll do hands-on with Istio and Service Mesh tomorrow. But do grab that book, and like I said, there's a tutorial and everything there. Now, I love this quote by Albert Einstein. We cannot solve the problems that, we cannot solve our problems with the same thinking we use to create them. So I want to challenge all of us as software engineers, software developers, to be thinking more creatively, think outside the box, think about how to solve a problem a different way. And that's the only way you can really start embracing a lot of these new techniques and technologies and processes and ideas, is by kind of just having a more flexible mind. Okay, so I love that quote. Because here's the great challenge, and I was just having this conversation in the exhibit hall area with another gentleman. Here's the great challenge you'll find at the organization you work for today. As a matter of fact, I met with several large, let's say, financial institutions just in the last 2 days before I got here. And they have this problem. They believe that dev, and I notice I call the dev there the programmer, they think they can rock on their headphones, writing their code, you're developers, we're all cool. And then on 4:45 on Friday, we can check that crap into the repo, and some poor operations person will figure out how to make that run. And they'll spend the weekend trying to understand what that thing was supposed to do, get it to build and deploy, and deal with all the ugly things showing up in the logs. Yeah, fix our sign. Okay, so if this is the world you live in, this is actually a problem. And this is actually a huge problem. I want you to go back and think about that first time you wrote code. Maybe you were 16, maybe you were 12, maybe you were 2, maybe you were 30. It doesn't really matter. That first time you wrote some code, what did you do after you finished typing it in and compiling it? What was the next thing you did? You ran it. Okay? And as a matter of fact, if it ran and it worked, you were so excited about it, you showed your mom. Because you're excited, your creation came to life and it worked. And one of the things we have a challenge with in IT is we've taken that away from developers. They never see their stuff run. They know it ran on their machine. They know they got it to compile. They ran a few automated tests, but that's it. They never see it run. And that's a huge problem. So that's really what I want you to think about here. We have to remove this wall of confusion between dev and ops. We basically have to work it together, because right now this throwing it over the wall concept, hoping that they fix it, they will deal with it, they will pick up our mess, is a problem. Okay? And as a matter of fact, if software development looks like this in your organization, a great mass of people, a huge team working with this amorphous blob, pushing that blob uphill and trying to get it into production, you'll notice there's also some people in some interesting positions here. Like, who is this person pushing back down? If you're in development, you think that's ops, right? You're right, change management, the PMO. No, that's actually our DBA. I'm kidding if anyone's a DBA. But even better, who's this person trying to ride the blob? They think they're in control. All right, that's your enterprise architecture team, right? The people who come from the ivory tower and give you standards. You got to use this web logic forevermore with Java 6, even though we're Java 10 now, kind of thing. Or how about this poor person under the bottom here, getting crushed under this amorphous blob? That is, in fact, your ops team, okay? Cleaning up your mess and trying to make this application survive in production. And what's worse about this, if this is how painful it is to deliver software, and I really had multiple meetings this week where people were like, oh yeah, we do this every 3 months. 3 months is too slow. But the reason you do it every 3 months or every 6 months is because it's so painful. You don't like doing it because it looks like this. And the first time you get over the cliff there, over the hump, you got to do it again and again and again. And so I love this quote by this gentleman. Don't be too proud of this technological terror you've constructed. It's a great quote, okay? This is what software should look like in the modern era. A cohesive small team pushing in the same direction with a nice, tight, modular piece of software. Call that a microservice if that's what you want to call it. Getting that thing over the finish line. They still got to push it uphill. It still takes work. You don't get this for free, but you can at least be working in the same direction. And maybe you can basically break down that wall where dev and ops are delivering the software together. And so remember, as a software engineer, the person who has to write the code, compile the code, run the test on the code, you want to see it actually run. You want to be accountable for that software, even in production, and understand how well it runs in production, and know if it meets the business user's needs for whom you created that software. Okay? So here's the key question that you'll have to ask yourself. And you'll have to ask the right person inside your organization to get the right answer here. Do you consider custom software development, APIs, and apps a strategic advantage for your organization? Is that something that's critical? If you ask the big boss or the middle managers, how would they answer that question? Would they go, yeah, maybe, okay? Or would they say, you know, IT is kind of a cost center. We need to find ways to lower that cost, right? We got to deal with that cost. If they're answering the question about the cost center, you want to find a new company to work for, okay? You want to work for an organization that's fundamentally about taking digital assets created by digital creators, which are you. You're the magic in this future digital economy. We're the people who can build digital things and deploy digital things. No one else can do that. And there's only a few million of us out of the 7 billion people on this planet. So you want to work for an organization that fundamentally values your efforts to build awesome stuff now, okay? So find that organization that wants to build custom apps and custom APIs. This is the definition of serverless from the Cloud Native Computing Foundation. So now we're just talking about serverless. That's all my preaching. Is that cool so far? Okay, not bored yet. We're doing good.
Yeah.
Okay, so let's talk about serverless. That's really what we're going to focus on in this session. You saw the demonstration we did earlier, but this is actually a definition you see from the Cloud Native Computing Foundation about this topic. So, you know, serverless refers to the building and running of applications that do not require server management. So serverless is actually a misnomer. There are still servers somewhere. These programs you write aren't running on air, okay? They're not running on water. They're running on silicon and plastic. They're running on hardware. The difference is, do you as a developer or the team building that application, do you see that hardware? And if you don't see the hardware, if it's removed from you, then that becomes more serverless to you. Whether you run in the cloud or the private cloud, public cloud, as long as it's removed from you and it's fully automated, you just deal with running your code as opposed to worrying about how that hardware is configured. Another aspect of it is it has a finer grained deployment model. You'll see this in the demonstration. You'll see it, you saw it in our demonstration earlier today. And you bundle one or more functions together. That's simply it. It's just a function. It's just a small piece of code. The nice thing about it is it can be executed and scaled and even build at a very fine-grained way and basically on demand. That's another aspect of this architecture. It's async and event-driven in all cases. So we'll keep going here. This slide represents a short history of serverless. You've seen this slide from me before, perhaps, for microservices. But we've actually been thinking about this serverless thing for quite some time. You'll notice that the serverless term was coined back in 2012. So it's been a few years since we've had the term. It actually came out and I found the article. The article is linked there. So all these are links. If you have a link to the slide deck, you can go look at these things. But you can see there's a number of players in the serverless game at this point. It's not just Amazon Lambda. And what we showed you in our demonstration earlier is the functions you create using Kubernetes now, using OpenWhisk and using technologies like that, open source technologies, are fully portable across all clouds. It's not locked into any given cloud. Okay? So definitely check all those guys out, and there's plenty more. And the reason I put this slide here, all right, so you can see we did this in 2016, this in 2017. This is what we did this morning. This is a picture someone took from the audience this morning. We showed you can run an application, microservices and functions, and we didn't actually show you running it across multiple clouds. We had done that previously, but it's fully portable and fully capable. So I consider that an important moment in IT history at this point. Everyone's going to start talking about how they can build portable functions going forward. Okay? It's not just going to be us, Red Hat, or what we showed you earlier. So here's what a JavaScript function might look like. Okay? You can see it basically has basic input parameters and has output parameters that are JSON based. And this is a very simple little application, a little bit beyond Hello World, but mostly Hello World, that basically iterates through the parameters. This is what it looks like when you actually do the updates to it. So we use the OpenWhisk open source project. We use the whisk command to basically update that code in the runtime environment. You just say whisk, action, update. That's all you got to do. And now that code is deployed in production if you have access to the production environment. And then you can say whisk, action, invoke just to run a quick test of it. Let me just test it. You can also just use an HTTP command, right? It's just you can actually do, just hit it with HTTP. And then you can kind of see how it acts. And then you can also get these activations. And this is the Python version of the same, because you can write functions in multiple languages. It's a kind of a polyglot platform. So very similar idea. You do the action update, you do the action invoke, and then of course you get your result, and then you can see your activations. Now, how many people here are Java people? Raise your hand, please. All right, good, good. I was expecting lots of Java people. So this is what it looks like in Java. It's a little bit more verbose, statically typed language and all that. And the actual, you got to do this Maven clean package, right? That's what we do. You got to build that jar file. And the command for doing the action update is a little bit longer. And you can kind of see there's the target jar file again. And you also see the main method is identified. Because in Java, you kind of have to identify what your main method is. What is that first class that should get invoked when the function event comes in? Okay, the invocation is the same as it was before for JavaScript or Python. And you can kind of then see what the answer is. And you can get your activation. So the good news is you can write your function in different languages. You just have to use the language of your choice. So what we're going to do right now is Kamesh is going to just show you what we just walked through and give you an idea for what that hello world looks like and kind of map it, just walk through what you just saw.
Okay, thanks, Burr. All right, so let's quickly start running this. So this is the code piece which just Burr showed us. So we have the same JavaScript function, just going to create the first JavaScript function here. So I'm just going to go to my CLI, and then say this dash I action create.
Make the font bigger, a lot bigger. Okay. Is that better for people in the back? You have good eyes.
Can we say you come forward? Okay, so what I'm going to do is I'm just going to do whisk an I, action.
Oh, is the mic not working again? Here, we'll do this. I got it.
Oh, thanks. So and then I'm going to do create, and then give the function name. Let me call this SG greeter, because I already have a function called as greeter earlier. So and then I gave the class name JS. Right. The moment I do, the action is created, and then I'm going to do invocation as Burr showed earlier. I say action invoke. Okay. Yeah, thank you. And then I have to give a parameter, I guess, right? So let me quickly check that. Okay. I can give a parameter. Go back to the slide. I just grab the parameters that I need to do here. So just gonna copy this. And there we go. So the moment we do this, we get the result back. And then now what I'm going to do is I'm just going to open up and save the next one, which we talked. We are to do a Python function. So here it's quite interesting that I'm not going to do just going to do an update. So there's no code change, there's no redeployment, nothing is going to happen. So if you see this Python function, it's pretty much the same as your JavaScript function, only the language in which it is coded is different. So I'm just going to take this up and then do again. There's no change again from here. So the invocation could be the same thing. I'm not changing anything in the invocation. There we go. So we got this now from the Python workload. So right, from the developer perspective, there is no change. Whatever he has to do, you can change any language you want at his convenience, but then deploy the same thing again, send the same parameters again, so the client is not affected because of whatever the function runs changes, right? Let's do the last one. So let's go and quickly go and do the Java one. I go to Action Java. I just say I'm clean package. Okay, you are all good. The cool thing about, I'll come back to this in a bit. So I'm just going to go back to my command and then say, okay, take this action and then update again with the new Java class. So I'm just going to go back, say update. I'm done. It's going to invoke the same stuff again. No change to the code, no change to client, and now I get it from Java. Right? The cool thing about the Java functions is that so I don't need the testing becomes quite easier. So if you see this, it's kind of a main class that is getting invoked. So I don't need to change much from the coding perspective. Can have a more robust testing thing with simple JUnit. No complex testing framework is required. And then there you see that my function is run and the test case is done. All right? So it's as simple as that. All right? So there we go. Back to you, Burr.
Okay. So we got more stuff to talk about, but hopefully that kind of gives you a little background on what a function looks like at the simplest level. And I love the fact that you can just change out the implementation by simply updating it to the next language you want, Python, JavaScript, Java. Okay? So let's talk about when you would pick a microservice versus one of these functions. So this might be the most important slide in this whole presentation. And it has to do with how much control you want over the execution of that code. With a microservice, you're fully in control of that code. Just like you were with a monolith, a microservice is essentially the same programming model, almost the same exact deployment model. You have the ability to basically start it, stop it, kill it, run it longer, run it less. You control its life cycle. That's a key element. Typically, a microservice is wonderful for long-lived processes. What you saw in our demonstration earlier today, right, we used Vertex as our microservice, and it held a real-time WebSocket, bidirectional WebSocket to the actual mobile phone. So if you need a long-running process that's always up and always on, maintaining socket connections to different clients, that's more of a microservice. Okay, that's just more what you would do there. And also, the nice thing about a microservice, it is a known programming model. Much like you guys have gone from WebLogic or WebSphere to, let's say, Spring Boot or Wildfly Swarm or some other solution, you can kind of just copy and paste the code right over, right? I've seen many people do that migration. It's a copy and paste migration. The programming model is identical from the old monolithic world to the microservice world. You almost didn't have to learn anything new. But in the event-driven world, you can kind of see the programming model is very different. The way you write code is very different. And as a matter of fact, things like Spring or Hibernate and other tools like it are actually fairly heavy in this function world. You don't need them as much in this function world. You don't need all that dynamic class loading. You don't need all that object relational mapping. You don't need all that other stuff that we've had in a traditional app server-like world that was an always-on, always-up process. These processes kind of come and go. They're ephemeral. Okay? So we also focused pretty much on the sync request-response model in the case of microservices, right? A request comes in, a response comes out. You get the same with functions, but it's a little bit different in this world because it's truly event-driven and always async. And for a lot of people, always thinking asynchronously is actually a little bit hard. In the case of microservices, there's incredibly mature IDE integration. We got IntelliJ, we got Eclipse, we got even NetBeans out there, with, and Visual Studio Code. You actually will see us use Visual Studio Code a lot because we actually donated the Java integration to that from Red Hat. There's already been like 4 million people, 4 million downloads of the Java integration with Visual Studio Code. It's a great, lightweight, not really an IDE, it's more of an editor, but you have a debugger, and you have a compiler, you have everything you need. So you get debuggers, you get tracers, you get monitoring, you get a nice CI/CD pipeline, all that is very mature in the microservice world. It's very well known to us. We've been doing it for a long time. In the function world, these are not quite as mature. We don't quite know how to do debugging with a function just yet. We're working on that. We have people within Red Hat that are actually experimenting with that. We don't really know how to do tracing and logging with functions. Again, these things are maturing right now, and we're seeing them being explored. And if you guys actually downloading the technology we mentioned earlier, going to GitHub and trying the serverless examples, and running it on Minishift on your laptop, like Kamesh is running it here, or running it even in our online interactive solution, we want your feedback. What do you think about that user experience? Are you getting what you want out of it? And I want to hear the question from you. I can't figure out how to hook up my IDE so I can debug that function. I need that capability. We need that feedback so we can make the product better. All this is open source, and you guys have the opportunity to come and contribute by simply asking questions and giving us, what we need to do better. Okay? All right, so just keep those two things in mind. So here's the good and bad about serverless. On the good side, you get automatic scalability. You get automatic cost reduction. You get a quicker and easier development model. The development model actually is very simplistic. You can actually write your code faster. You can also get better capacity planning. If you do this right, you get better delivery speed. But on the bad side is the debugging, the deployment, the architectural complexity, the new programming model. Potential vendor lock-in is a big problem at this point. If you write your function for only a certain cloud provider, you're locked into that cloud provider forevermore. That could be a problem. It could be a concern for your organization. But these things, again, are being solved. So there's just a lot happening in this serverless space. Now, I love this quote from the ThoughtWorks team from November 29, 2017. The first question you should ask yourself when you're thinking serverless, I want to be a serverless architected application, is there a service I can consume? This is how it becomes more serverless to you. Instead of trying to do I write all the code and I basically invent everything on my own, think in terms of, is there a service I consume? And this might sound kind of crazy. For some people, like, wait a second, I write all my services. Other folks are like, wait a second, I've used a database now for years. I didn't write the code for the database. That database sat over there, and I connected to it across the network. That could be important to you. So think about that. Before you build something, can you buy something? It's the old buy versus build trade-off. So it's a great quote there. So it's really serverless because of software as a service. You will basically take advantage of all these existing services that exist out there and leverage them to build your application. So in other words, you're not going to rebuild Twilio to send text messages or make phone calls. You're going to just use Twilio. Does that make sense? You're not going to rewrite Salesforce to do your own CRM. You're going to just use Salesforce. That's really the magic behind serverless architecture. You're not going to rewrite a database engine to put things in a database. You're going to just use a database, one that's available to you and you can actually wire in from an event standpoint. So all these, our sign keeps falling off here. Okay? So it's all about the services. So in the case of like HTTP, input and output, most of us use HTTP as a way to get in and out of our system, whether it be a get, put, post, or delete. That might be an API gateway as a service. We might also, like we saw in our presentation and demonstration earlier, some form of SSO as a service. Yes, you can write your own single sign-on solution like the one you saw us demonstrate earlier, right, with the ability to do OAuth providers and broker and do the registration screen and the login screen and forgot password capability. You can certainly write that, and I imagine people here have. Or you can just use the service that's already out there for free. In the case of Keycloak, right, it's an open source technology. You can take advantage of that. You can also have storage as a service. We kind of showed you that in our presentation demonstration earlier. We had Gluster as our distributed file system. It's taking care of storing those files for us. We didn't have to write that code ourselves. We just took advantage of it once we installed it and got it out there. You might have caching as a service, right? Many of us use caching now inside of our application architectures, and I want the cache to be, available to me. I don't want to rewrite that. Some of you probably have written your own cache before. It's actually not really hard to do a simple one, but it's really hard to do a complex one with really nice capabilities. Maybe a database as a service, maybe messaging as a service, all right, or notifications as a service. You can write all these things yourself, or you can find somebody to give it to you and work with you on it, and then you simply write the business logic that starts connecting it together. You can have your long-lived, high-control processes, otherwise known as microservices. You might run them in a container, a Linux container, like we showed you with our OpenShift demonstration earlier, and you can just simply run those through a CI/CD pipeline. All that works really nicely with a nice immutable image and moves out to production with your Java application, your Node.js application, your Python application. All works well, but those are the ones you have high control of. But you can also then use serverless functions as the connective tissue that actually wires up the rest of the application. And the reason this might be important to you is you can then rewire the application as needed based on the different way you want these events to be fired. So just think in terms of the event-driven input, event-driven output, and how to respond to events throughout the system. In our demonstration earlier, right, we had the file get uploaded from the mobile application and drop that photograph that was uploaded from your phone into our distributed file system known as Gluster. And then we had a function simply looking for that event, pick up that file, send it against YOLO, score it with a machine learning algorithm, and provide back a score. And then we had a notification service, right, that basically then said, I got the score inside the data grid, send it back down to the actual client. That was kind of the whole purpose of that demonstration we did earlier. So all of these, of course, you can have various business-to-business or desktop or mobile applications consuming these APIs, consuming these services. But this is now your whole of your application. Okay, your application now is this more complex beast representing multiple microservices and multiple functions all in one composite whole, which is exactly like the demonstration we showed you earlier. Does that make sense so far? I know, it's late in the day and it's late after lunch. People are like, oh, okay, yeah, it's okay. We'll keep going here. Here's another great quote from this guy. Do you know this one? Yeah, I like this quote. Our ancestors called it magic, but actually in the movie he calls it, what you call it science, I call it computer science, but I come from a land where they're one and the same. So I make that point again. We are the people who actually can make things, magical things, because if you actually know some people who aren't in the computer field, tell them what you do and watch what either they basically shut you off like, I don't know what you're talking about, or they think what you do is magic. So I think it's an important point. And we're just looking for new ways to do more magic. Here are the function as a service players in the Kubernetes ecosystem, and actually there are a lot more than these. Okay? There's a new one showing up every month, it seems like, or every week. As a matter of fact, I heard one presenter give a presentation on function as a service and serverless architecture, and he said it only takes one good software engineer about 2 months to build one on top of Kubernetes. So we did. And he did, right? He demoed his function as a service serverless solution on top of Kubernetes. So you can actually build these things rather rapidly because Kubernetes, by default, gives you a lot of capability out of the box. The concept of easily scale out and scale back, right? That's just built into the concept of Kubernetes. The ability to basically launch something and run it, keep it running all the time, keep a bunch of these things running. You get a lot of that. So you should just keep that in mind. You're going to see a ton of players in this space, and you're going to have to decide which one of these players do you wish to bet on. Because I can guarantee you there will be consolidation in this market over the next several months. Some of these players will wither to nothing over time. In the case of Red Hat, we've bet on Apache OpenWhisk right now. So that's the one we're looking at and the one we've been focused on, the one you saw earlier in today's presentation, and the one you saw, we'll see at those endpoints, those URLs we mentioned earlier. With OpenWhisk, we bet on it because IBM already has it in production, and as well as Adobe already has it in production. So it is actually a proven function as a service engine and capability that's already out there being used by real people already today. Some of these others are, just really brand new projects that may have one developer working on it, or because again, it only takes one person 2 months to build one apparently. Might really have just one person on that project. I might have maybe a few more than that. Some notable ones, though, I think, that are listed here is FN project from the Oracle team. I think they'll do a good job integrating Java as an example, and they're working really hard on it. It's from the ex-Iron.io folks, so there's some interesting things happening there. Also, the project Riff you see in the lower right-hand corner here, that's from the Pivotal team, the folks who gave us Spring. And so there's some really interesting stuff that they're doing there. So you have to watch those folks and see what they come up with. And there'll be more players that enter this space. For instance, one player who's not even entered the market yet is Google. Okay? So what are they going to bring to the market when it comes to functions? It could get really interesting really fast, based on what they do. So we have to kind of monitor all of these things. Now this is an important slide to understand better what your responsibilities are in this function as a service world. Okay, you can see there for on-premises, you are responsible for the full stack of the application. In other words, somebody had to actually provision hardware. You might have had to wait 6 months for something to get shipped to you and get racked and stacked and racked and powered and pinged, because we were responsible for everything there. You can then see when we moved into the infrastructure as a service world, we weren't responsible for the server hardware or even the storage in that server, right? How many disk drives it had. We weren't necessarily responsible for the network layer, but we were still responsible for the upkeep of the operating system. We had to patch it at that level. We had to worry about the JVM or the Node.js V8 runtime. We had to worry about the data and the application, the business logic. So that's where the cloud, though, kind of entered the game. That's where EC2 showed us we could do these things with infrastructure as a service. You can see for containers as a service, we basically now have kind of thought about this concept of containers, and then platform as a service is fairly similar. The difference between container as a service and platform as a service is primarily how much additional developer experience and capability you put on top of it. Like how hard is it to build a container? How hard is it to deploy that container? How hard is it to monitor that container? And you can kind of see for the backend as a service, you kind of just focus on the business logic, and then with function as a service, it's just the business logic. You worry not at all about any of the other infrastructure concerns. So that's one reason that function development can go faster, because you're worried less about the rest of that stack. In the case of a container as a service, right there, that one right here, you have to worry about your Docker file, as an example. Okay? You got to build one, and it matters. You need a Docker file, otherwise things aren't going to work quite right. You might even have some Kubernetes YAML. We can even show you that. We have a bunch of that running here on these machines. But in the case of a function as a service, you notice when we showed you that demonstration, there was no Kubernetes YAML, there was no Docker file, there was just your code, and only your code. And that matters a lot. Like I was working with another cloud provider recently. I had to have this very special JSON file. It had to be in a certain directory location. I had to have yet another JSON file that had to be yet in a different directory location. And if you got that even slightly wrong, you just got error on the screen when you tried to deploy it. It didn't give you an error like made sense. It just said, sorry, we can't deploy, error. That was it. So you want to be in an environment where you do focus mostly on your code, and there's no special magic that requires it to be deployed, as an example. Okay? So we'll keep going here. Apache OpenWhisk is an open source project incubating at Apache. It's a function as a service platform, and you can execute functions written in JavaScript and Swift and Java, Python. You saw Python, Java, and JavaScript earlier. You also can write your functions in Go, and you can use any Docker container, right? Any Docker image that has your application running in it. It could be a native COBOL application if you can make that work on Linux, and some of them can. And that could be your function, okay? That could be kind of awesome if that's what you want. And it's deployable to wherever Docker can run. And of course, what we've been doing at Red Hat is focusing on deploying it on Kubernetes and OpenShift, just like the system you saw earlier when we did our keynote demonstration, okay? So there's a lot of cool things in here you have to kind of start learning about OpenWhisk. For one thing, you saw in the demonstration we did earlier, there was this concept of actions. An action is a function. So when you have to kind of map your head to, oh, a function, action. They call them actions over here. That's all it is. I think that's kind of cute because I remember struts and struts actions. As a matter of fact, the very first ESB, Enterprise Service Bus I worked on, called them actions. And all they are is just your blocks of code that respond to certain events. In the case of struts actions, they responded to get, put, post, and delete. For those of you who are old enough to remember struts, maybe most of you aren't, okay, at this point. So you also have the concept of package, right? You can bundle these actions up into a package. It's not a Java package. It's its own package concept. You have this concept of a feed, and the feed is actually very important. The feed is actually the component that ties into the event stream, and you have to have the feed or feed provider for the event streams you wish to listen to. So this is the big gotcha, if you will, in the overall serverless ecosystem and serverless community for any one of these projects that are trying to win your hearts and minds for their efforts. I believe the team that actually gives you the most feed providers, the links to those event streams, will probably win the day. In other words, I want to listen to HTTP. Great, most people do. I want to listen to AMQP. That's another protocol for message brokers to message brokers. I want to listen to just TCP. I want to listen to an email coming in or a text message coming in. I want to listen to things changing on my file system. And if you guys have actually seen this sort of thing before in other communities, for instance, if you're familiar with Apache Camel, another project that Red Hat sponsors, it has something like 200 plus of these connectors already. It can listen for SAP things. It can listen for, Salesforce things. It can do all the HTTP and files and things like that I mentioned earlier. So the feeds are super critical to manage the integration with that event source, okay? You should always be thinking in terms of what's my event source and what's my possible event sink in this world. You have the concept of a trigger, and you can also schedule these things through these rules and triggers. So you might have like a cron job. It's really easy to build like a reoccurring cron job in function as a service in an OpenWhisk. I can basically say, here's my code, run it every hour, run it every 2 minutes, run it based on just a timed event, which is pretty awesome all by itself. You also have this concept of the activation, and we can show more of that when we get to the activation piece. But you can think of the activation as the moment in time when the function has basically said an event has received, my code has been activated, executed, and that's actually how you pull your logs back out, how you get the logs out of that activation. And there is some little nuances there that are kind of tricky when you start using OpenWhisk. For instance, as soon as your code gets invoked, and let's say you just had system.out.println or whatever logging framework you want, you don't actually get the logs immediately. You get them asynchronously so many seconds later. And so you're looking at your logs and you're like, that's the log from the previous invocation. Look at the log, still the previous invocation. Oh, there's my invocation. So that can mentally kind of get you off out of your game, right, Clement? We felt the pain when we were working on that big demo. There is a nice archetype that could be available to you, so you just be aware of it. So it'll generate the base template Java project for you to get you started, right? So just bear that in mind, that you have access to that as a Java programmer. And if you install OpenWhisk on OpenShift, you will see these components. We'll show you this in a second, but you can see all these components that are actually part of the backbone of OpenWhisk itself. You'll see things like Apache Kafka there, which we call StreamZ. So for Kafka on Kubernetes, we call that project StreamZ. So it's kind of the fonts there are small. We can make it bigger in a little while. But just look for those kind of things in the background there. So there is a significant bit of work that's been done to make this whole engine execute. You just don't have to worry about that as a developer. You just hand it your code, and it takes care of all this on the backside. So now we want to kind of give you the next cool demo. Actually, we have 2 more demos to show you that really drill down and kind of show you some more meaty aspects of this engine. Is that cool? Okay, Kamesh?
Thanks, Burr.
I'll hold the mic.
All right. So we talked about a lot about Java, but you'll be wondering why did we do the Java here, right? So what I'm going to do here is I'm just going to build you a sequence application, so where it's going to pick up a string and then convert that and sort and all these stuff. So to get there, I also want you to get familiar with our tutorial, online tutorial. We just say bit.ly. I think we have the links there, but I'm going to take you there, right there at the GitHub repository where we have this repository where you can find. So if you go to the solutions folder, the solution folder is already done by us, and then it helps you to do this, but it also gives you a detailed instruction on how do we actually do this action. For example, how do we create your Java action, and how do we install it, and how do we verify it, and all other stuff. So just to get a feel of it, I'm just going to use the same one so that you know how this actually the tutorial works. I'm going to go to this chaining actions, which is nothing but sequence of actions. So what I'm going to do is I'm just going to create this jar here. So what the first thing is I'm going to go to the splitter. So if I'm here, right here, I have 3 things: sorter, splitter, and uppercase. So the sorter, as you know, it sorts the strings, and the splitter will split the comma separated strings, and then finally it does an uppercase and get the results back to you. So I'm going to go to the splitter first. I'm just following the tutorial here so that you also know how it actually works. The first thing I have to do is maven clean package on this. You don't need to even install this because it's just going to use that directly, and then you already seen this command which we did earlier. I'm just going to say whisk action update. Let me make the screen much bigger for you to read, right? Whisk action update, and then I say create this action. This action is created right now for us, and then now what I'm going to do is I'm just going to go back, and then I guess I have to go to the sorter. If I'm right to the order, yes, I'm on the sorter, and then I'm going to do the same stuff again. Maven clean package, just to get things packaged up for us. And then I'm going to say create this sorter action. All right. So, uppercase. Okay, not a big deal. I'll just copy the command from here. This is the sorter action for me. I can just go there and copy the stuff again. So my sorter is done, and then I go back to the uppercase, just fire the maven clean package.
Go package.
So, and there we go, and then I can grab the command again to create the uppercase things. All right. There we go. So we have all the 3 actions created. Now the job left for us is to kind of sequence them up, right? There are 2 types of sequencing which can happen in serverless. One is that it's called a sequence, it's static sequencing, which I create at the time of creation. It follows the same static order. The input of the first command will be the output of the first command becomes the input of the next, and it goes sequentially that way. So there's also something called as conductor. So if I'm going to use conductor, I can decide on runtime which action to invoke later. Right? So here in this case, I'm just going to use the static action. I'm not going to use the conductor one. So the command to do this is very simple. If you've seen this, pretty big command, but just to see that if we have given the sorter, and then we're given the sequence of actions with the sequence parameter saying which are the actions that need to be invoked. Right? So what I do is before I invoke this, let me quickly refresh to see if I can get this one, so that I can show you these actions coming up, the pods coming up after every action is invoked. Right? So I'm just going to create this action. My action is done. So what I'm going to do right now is go and test. So as I told you earlier, the command takes an input, and then it's comma separated strings, split it up, and then deploy it, right? So the moment I say, let me fire this and then tell you this. You see this? The splitter is called first, the uppercase is called next, and then the sorter is called finally, and then there you get the result back here, right? The sequence of action, if you follow that, the sequence of action has got created. As Burr was saying, I could still pull the activation logs and see. For fun, let's do that and see the delay that is caused here, right? I'm just going to say whisk-i activation poll. So let's be like this, and you'll see the sequence. It will not be in the same order as we invoked just now. So you see the delay there. So the logs get delayed, and then the order of the logs is split. So first we split, next we uppercase, and then we sort it. That's what the order we saw. But here the order is jumbled, right? So we cannot exactly see this is an order just invoked, because you see that all the things comes first, and then the other logs of the other parts comes. And this is the delay which you're talking about, which means that it's written asynchronously. It's not synchronously written into the logs as well, right? So cool.
And actually open up the code real quick just so they can see it.
Okay, so that I can do. I'll just open the code here. So
And this is the Visual Studio Code I was talking about earlier with the...
So let's get to QuizLiter, and then if you see this function, it's again a single class, and then I get this parameter called as text, and then I kind of split this with comma separated string, and then sort it out, and then give as a response to the next one. As I told you that the output of this first command is going to be the input of the next one, right? So if you see the sequence, it's going to be uppercase next, if I'm not wrong. So if you see this uppercase, it's just going to take the same function again. It gets for the result in the JSON objects. As I told you earlier, the Java functions or anything in serverless within OpenWhisk takes JSON objects as a parameter inside and gives you JSON output, right? So I already packed this as a JSON object here with the response as result, and now what I'm going to try to do is I'm just grabbing the result up and then kind of doing an uppercase of this. So it's no big logic here. Once this is done, I'm putting back on the same thing so that my next function can take this parameter and then kind of add it again. So if I go back to see the sorter, again it's going to be the same single class. Grab the one from the result JSON attribute, and then do this, and then do a sorting of the string, and then put it back the result. So if you see the result, what we got here is again a JSON object with the result parameters, which has the uppercase split and sorted once here, right? So this sounds interesting, but we have one more thing a little bit more interesting now. So what I'm going to do is so do you have the slide bar somewhere?
Yes, back to the slides.
Okay.
One more down. There it
Yes. So if you see this, so this is again a simple demonstration of the same type of function, but what I'm going to do here is that I'm going to use Apache Artemis, where a message gets dropped, which is saying it's going to be the same string message what we saw just now. And then here, last time when you saw it was kind of homogeneous functions, right? All written in Java. Now what you're trying to do is we're returning 4 different functions written in 4 different languages, making it polyglot. So the moment we're talking about feeds, it will listen for the messages that gets dropped. The moment the message gets dropped, it fires a trigger. The trigger fires a rule, and the rule starts doing all the sequence of actions that we're doing here for. And finally, your JavaScript function is going to take that and put it back in the message queue, where you'll see the message coming back in my message queue. Okay? It's pretty much the same one, but we are trying to make it polyglot and kind of to show that how feeds work, and how we can write your own feed provider as well.
And the gopher there is for Golang.
Yes.
I suppose we're
Yeah. Cool. So I'll come back to the source code again after some time. So what I'm going to do is I'm just going to start this simple receiver. So it's just a simple receiver class. I'll just clear off whatever I had earlier. So we had some functions already done here. So don't go by this log again. So I don't want you to go here. So what I'm going to do is I have a Java code, which is a simple AMQP based code, so which can listen to any parameter. I'm not using JMS here, it's AMQP protocol. So I'm just going to push some message the comma separated string, all these things back to this. So let me quickly see how.
Is that American football or European football?
It's a football, it's a Brazilian football. Yanaga?
Okay.
No, it's not here. So, all right, so it takes some time for this to get back. So I have to do a bit of refresh. So the moment I make my computer sleep, some magic is happening. So I have to go back and then try to delete the rules. So this is again, this tutorial is part of this advanced thing. So you can find this up right here. So what I'm going to do is, like, for the clarity's sake, I'm just going to say you what I actually do to get these things working. So I'll come back to the source code of the functions. Again, the same set of function, but written in 3 different languages. What I'm going to do is, like, I'm going to delete the trigger so that I'm having everything fresh, and then show you what happens. So I'm going to delete this, and then yeah, the trigger is deleted, and then I'm going to delete the action as well. So I'm not, let me not delete this. I'm going to delete the rule that gets triggered, right? So which is responsible for the action to run. Okay. Action, okay, sorry.
Delete.
Yeah, delete. So let me quickly say these things to you. So first thing is, what you're doing here is, like, we are creating a trigger. You say I'm going to create a trigger from, I'm just had a feed written already. It's a feed action, it's a standing microservice. So which is kind of listening to the messages that is getting dropped into the Artemis queue. And then I'm going to say a parameter, passing a parameter saying that which is the address I had to listen to. It's a simple queue, I'm just called as Q99. So it's going to listen to Q99. So any message that gets dropped into Q99, this action is going to get that, and then it's going to pass this, call this trigger again. So the trigger is there, but you have to link the trigger and action. So that's what we do with the rule. So with the rule, we say, okay, match this trigger with this action. So what's the action? That action is what you created here. Split sort use case. So which is again a sequence what you saw earlier, splitter, sorter kind of thing, but written in 3 different languages. Sorry, 4. And then we say that, okay, create this rule called as rule splits use case, and then it takes that and then map it to the trigger, and then which action to be invoked. So once a moment you get the message into the feed triggers it, the triggers knows which rule to call, the rule knows which action to call. So that's the sequence of things which you do, right? So let's go back quickly, create it again so that I can demonstrate this back to you. So so I use Artemis, but this is using AMQP, so you can use any kind of message provider, so it's not restricted to Artemis, but I'm using Artemis here. So I'm just going to create a rule now, matching the trigger. The moment it is done, so I can just start my receiver here, and then I pump a message from my queue. Right? So from a Java class, it goes there, and then we wait for some time. Should get it soon. Yes, you got this here? So you see that the fag end of that, you see this sort of split sort and all of the action getting created here. So for the clarity's sake, I'll fire it once more. And then let's also have this guy here so that you can see which actions are getting invoked. So go back to my code, invoke it. Let's see what happens here. Right? You see splitters, UKs, sorter, and message center. So these are the sequence of actions that are getting called, and the message gets posted. The moment you see the message gets posted, and then you see the response back again here. Right? And then you also see that since these are not long-living functions, they die, the containers die immediately once the job is done. But there are cases where we keep firing them immediately in continuous intervals, shorter intervals, they keep to live for longer time. Right? So it depends upon how you use cases.
Well, one thing that's super nice about if you have your own function as a service engine, or if you have your own serverless architecture like this on your own premises, you determine what those intervals are, right? So you're not beholden to a cloud provider saying you got to run this thing within 2 minutes and the timeout on it is 60 seconds. You can pick all these different parameters and decide exactly how long it lives, how long it can run, how big of a function it can be. You're in charge of that with your architecture.
So I'll quickly go and show you the code which is backing this. Just going to use Visual Studio Code again to open this app. So you could see all these things are available on the bit.ly tutorial link which Burr shared, and we have all them in the slides, so you can go back this. We have one more integration where we did with Slack as well, so just to show you how Slack can be integrated with a function as a service, so that the message you can interactively use Slack to send messages, and your function as openness platform responds you back with the reply. Right. If you see the sender again, so this is split as a simple Python code, which is just there to split the thing, and then once you split it, I wrote a Go code, which basically sort things up, and then the only thing you have to do is like usually we do it in the servlet request, right? We want to take some parameters because the last function in the queue expect the reply to queue, so where I have to post the reply back. So what I'm trying to do is like I'm just carry forwarding the parameter, reply to parameter that I got from the first function onto every other function. So as I told you earlier, like in the sequence of actions, the first function is the one which gets all the parameters. All of the functions only get the output by default, but if you have to pass the parameters, I have to do something like this, like how you carry forward in a servlet request, right? So I'm just going to go there and then do the result. Again, as I told you earlier, just popping it back to result, and once it is done, and then it goes to the Java class. The Java class, again, it does the same thing. It takes the one and then do the uppercase of it, and finally it adds a property to the response JSON and then put it back again. The last function, which is JS function, which uses a AMQP protocol to put message back into the queue. So that's what you're doing here, right here. So we just say message, and then once we accept it, we're coming out here of this function. And then this is a simple class, the code. So it's a pretty simple one which just listens to a message. I'm just kind of setting it to 1 so that I can show one message, last message that gets popped up. So it keeps listening to the queue on the MQP protocol and then gets the response back and throw it back to you, right?
Yeah, if you would bring up learn.openshift.com
Yes.
/service so you can see what that is.
So you can also do here learn.openshift.com and then go to serverless. So you can kind of get these scenarios which we talked about right now. They're all available for you at the learn.openshift.com serverless. And guys who are going to miss tomorrow's workshop, unfortunately, we allow you to have there. If you're going to miss that, then you can also go to another thing called a service mesh, so which talks about Istio and all other stuff on all the tutorials which we talked about since today morning. So you can also go here as well. So people in the workshop tomorrow are going to use this. As well as if you are missing that, then you can go ahead and start doing this. The difference between this and the tutorial, what you saw in GitHub repository, is that the GitHub repository helps you to do it by yourself, step by step, setting up it in an old laptop. And here we have all pre-baked ones. You just need to learn the concepts here. So in case if you're not having a high-end machine or something like that, it's all browser-based. You can learn at your own pace as well. Yeah, all browser-based. It launches the VM in the cloud for you. You don't have to install anything, and it gives you a terminal to work with right inside the browser, versus the other option, which is you put it all on your local machine, and you might not have enough hardware on your local machine, exactly. Or you might have other issues. For instance, if you're an average person with a Windows computer, you might not even have the ability to do virtualization on it. Right, you got to go into the BIOS and actually turn that on, and a lot of organizations do not have that turned on. So, okay, so this uses Minishift. Probably if people are not known about Minishift, it's a single node cluster that can run your own thing. So this tells you how do you set up Minishift and then deploy OpenWhisk on it and then start working on this. So step by step with all the code pieces, snippets, everything given to you. So this is the difference between the online learning platform of this is that you don't need to do this step, basically. The thing which you're doing here, you don't need to do that, but if you're interested, setting it up on your own, then you can go to any of these two things. So I know we're almost out of time. We have to get on to the next presentation. Could you bring up the last slide, which has the link on it to the presentation? I think, or maybe it was the first slide. Yeah. Yeah. Okay, there we go. Yeah. Yeah, so just that, again, that serverless Java SG will get you access to this deck, get you access to all the other links. And then what I want you guys to think about now is, do you have any specific questions, any thoughts? I know everyone's tired, right? It's late after lunch, and we're at the end of the day. You've been sitting through a lot of sessions today. But do you have any questions or thoughts or crazy-ass ideas? We'll take anything. Bruno's already gone to sleep on us. Yeah. So, and we work with him. Now I woke him up. But what are your thoughts? Anyone here interested in trying this stuff by showing you? Were you interested enough to go, hey, I want to try that? You might try the online thing. Okay. You might want to install all this cloud on your actual machine, like running Minishift on your local machine, having a whole cluster there. That could be an option for you. Yeah, you're interested in that as well? Okay. But any questions? Yes?
Does OpenWhisk has plan for supporting cloud events?
Cloud events?
Yes.
Yes. So actually just a couple weeks ago at the KubeCon in Copenhagen, one of our folks was there doing the cloud events interop. So and actually let's bring up a browser tab and go to cloud events.io. If you're not familiar, and this is actually a very good question, so thank you very much for it. We should put this in the actual presentation. What's happening in this world of multiple FAS providers, multiple serverless providers, the real lock-in, if you will, is the event streams. And so the cloud events folks are basically trying to basically standardize what those event streams will look like. What does an event look like? So they've already done an interop event where multiple vendors got together, including one of our folks with the OpenWhisk, and they actually showed that they could all receive an event from S3. And that sounds kind of funny because S3 is Amazon only, but there's a way to broker all those S3 events into other people's functions as a service, and that's what they were demonstrating. So that was rather nice, and it just happened a couple weeks ago. So all this is still very new, but I encourage you to check out Cloud Events.io as one option for that also. And actually bring up serverless.com when I think about it.
Yeah, I think there's one more option to what Burr was saying, that you can also listen to other cloud events. For example, I'm running an AWS Lambda function, and I want AWS Lambda function to invoke my serverless function, OpenWhisk function. Even that could be done. I think the serverless.com has something called as event gateway. Mm-hmm. So you could just see this here. I just need to blow this up. Okay, you can see this event gateway right here. So you can have your event gateway deployed. And once you have the event gateway deployed, it can make you to talk to other stuff. If you see this, the diagram which these guys have shown to you, there's numerous options for you. For example, I can talk to Lambda, Azure, Google Functions, even raw Kubernetes, and then even also I can do AWS Keynotes, and a lot of other options available. So you can deploy your event gateway into your system along with OpenWhisk, and then it can start talking to each other.
Yeah, it's essentially an event broker, event stream broker. Okay, so there's definitely a lot of work in this space. It's still, got to mature, right? This is all net new, but I'm very excited about these particular projects because it will help out with those kinds of things, the concept of cloud events and getting those event streams more, portable, if you will. Awesome. Any other questions? And I know we got to get ready for the next session. Yes, sir?
Actually, we are using Google API to communicate between different actions. Is it a common specification?
You're using the Google API for what?
I saw to add all the responses in the Google JSON.
Yes.
Oh.
To communicate between different actions. So, is there any, so that it can, two actions can communicate?
Right.
Common specification, so that you can move from one provider to another provider?
But in this case, if you bring up the code again, it's not an API per se, it's just the JSON. It's just the JSON handler from Google.
So this is only for Java, and to be very precise on this, so we are working towards taking this out. Maybe the newer version of OpenWhisk will not have this dependency right now. It will use some common specification. So we are not yet deployed that yet. So we're still working on how do we actually get that thing done. So, but this is a restriction. This is only for Java because Java doesn't have any other way by which I can construct the JSON. So I have this.
Yeah, this is not binding you to Google in any way, right? Like a Google hosted service. It's purely running here inside the system. Yeah, it's just like any other, like Spring or Hibernate or any other jar file you would use.
So the other one which I have here is serverless. OpenWhisk is that OpenWhisk can run in any in your own data center as well, as I said earlier. But if you want to run for AWS function or Google function, I need to subscribe for AWS or Google Cloud. So that's a big difference between these two things.
Okay, but we can certainly take questions offline because we got to get out of here.
Quick one.
Yeah?
What would be the difference in terms of performance between autoscale pod or container versus serverless?
So great question about auto scaling of either at the Kubernetes level for pods or even at the VM level if you're dealing with like EC2. So all these functions, if you notice, what OpenWhisk does something very clever. You can actually have your pre-warmed pods, and it does keep a pool of pods, if you will, and it's injecting your code dynamically kind of when the event comes in. So they are trying to even further optimize it so you're not even waiting for a pod to wake up and run. All right, because even a pod start can take several seconds depending on the nature of your environment. Does that answer your question? And so it has an optimization for that. The market will determine if that's the right way to do things, because in the case of a JVM, you have some concerns around that. But in the case of JavaScript or Python, it actually works really, really well. We did fix a bug on the Java side of it just because it wasn't working so well. That actual demo you saw us earlier, we benchmarked it so heavily, we actually found the bug in that demo. And then we had to go contribute that back upstream. Okay, we're out of time, so thank you guys so much.
Thank you.